Uh, Good day, everyone. I want to welcome you to another statistical machine learning class. Of course, today the focus is going to be, we started a new topic that we call test data and topic models. Let me say this. I've uploaded my recordings for last week. You can check the model. Okay, the recordings are now uploaded. And of course, I'm also recording this. So you're welcome to this particular topic. And let me remind you, we are meeting in person today. On Wednesday, we're not going to meet in person. It's going to be online. Or what you just need to do is to join or Zoom. Okay, so this topic is text data and topic models. You, we are meeting in person today. On Wednesday, we're not going to meet in person. It's going to be online. Or what you just need to do is to join or Zoom. Okay, so this topic is text data and topic models. Um, in the outline, I'm going to introduce you to that and also to walk you through some topic models. Okay, so the topic models, we got latent semantic analysis, we got NMF. Of course, we've done non-negative factorization technique before. So that can also be used as a topic model. Then also going to walk you through latent, the trishlet allocation that we call ADA. Then we're going to talk about probabilistic latent semantic analysis. Okay, so let's get started. Let me tell you this. I first want to tell you the reason why we find ourselves doing what we want to do now. Of course, you've come across documents, and documents could be an article, could be a paragraph, could be a sentence. A document is a unit of a text, that can be all of that. And in each document, there's going to be some kind of words that form topics. We call this a topic models because we actually want to have a way to extract some topics from document, but the way we're going to do it, we we have a text data. We need to first have what I call a numerical conversion or numerical representation of text data. Okay, when we convert text data in a numerical form, then we can now use machine learning algorithm to learn the topic. We will not be able to use machine learning algorithm to learn the topic. Okay, when we only have a raw textual, um, kind of representation. So what we're going to be doing here, we actually we're actually going to have a numerical representation. And what I mean by that numerical representation is going to look in form of a matrix. Of course, you're going to benefit from the idea of matrices in mathematics here. Now, extracting a topic, we do that a lot in natural language processing. According to ChatGPT, the natural language processing that we call NLP is a field of artificial intelligence that focuses on the interaction between computers and humans through natural language, aiming to enable computers to understand, interpret, and generate human language in a valuable way. Okay? And let me tell you this. We actually, because we want to extract some hidden topics in documents, okay? Because we believe when we talk about topic, Okay, topic is a combination of words. Okay, the combination of words that occur frequently together. Okay, so how can we actually extract some topics? For instance, if you look at the newspaper article, of course, you're actually going to have, they reported different topics, right? Like sports, politics, economy, and so on like that. Without four of us seeing the topic, is there a way I can actually extract some words and using the topic or the idea of topic modeling, to be able to figure out what the topic is likely going to be. Okay, I know if I hold an article and I say something like numbers of runs, numbers of, or let me just say, I say something like the numbers of points, the numbers of rebounds, then I'll be able to know that probably they're talking about basketball. If I say something like the numbers of goals scored, or the numbers of shot, the numbers of corner kicks, and so on like that, then I would know they're talking about soccer. So what are those things I'm actually going to see in words? For me to be able to identify the kind of topic, the words we come from. So let me tell you this, there's nothing in the world that we cannot model. I told you from day one, a model is a mathematical representation of reality. So in textual analysis, can also apply mathematical model. The only thing we need to do is for have a numerical representation of text data. The moment we have a numerical representation of text data, we can actually use a topic models. So topic modeling is a collection of statistical and machine learning models to discover what? You want to discover hidden abstract topics in a collection of documents. Let me tell you this. The collection of documents for analysis, we call that corpus in topic modeling. Okay? So, and this task can be regarded as an unsupervised learning. We do not, it's an unsupervised learning because initially we don't know the topic, right? We will actually want to use a combination of words that we have to be able to identify the particular topics. So because of that, we're going to call that an unsupervised learning task. And let me also tell you this. This is another dimensionality reduction procedure. Because why not taking the article myself? Why do I need to use a model to make a prediction? Because if I spend my time on the paper and it means I'm actually gonna go through everything for me to know all those topics. And in that case, I'm actually referring to that as it's an high volume. We don't have that time. Is there a way we can save our time? Just looking at the combination of words and to be able to predict what the topic is going to be. And that's why I said, at a high level, topic modeling is a dimension reduction procedure that focuses on the text data to generate reduced dimension with more meaningful interpretation in the context of languages. Look at that, reduced dimension, which means initially it is a high dimensional data. So by the time we are curating our matrices now based on the text, the matrix is going to be high dimension because we're actually going to arrange the documents. It's going to be document is going to be in a row and the word is going to be in column, where in each cell, you want to be able to know the number of word in a particular document. And that is actually going to be a matrix in nature. And if the moment we're able to know, this is a good news. if we are able to have a matrix generation, like we're able to construct a matrix, then we can actually benefit from idea of matrix factorization, okay, in achieving our aim. I need you to pay attention, take a look at what I'm showing now. I have a collection of text documents. Do you see the collection of text document right here? The collection of text document is actually what we call corpus. We call it corpus, okay, that we want to analyze. These documents are a lot. And in each of these documents, we got hidden topics. Okay, we got some topics. And let me tell you this, what are we using here? We're using a topic modeling. This topic modeling is like a black box. It's like a black box. A lot of things is going on that we may not be able to see right now. So what is happening? You can see that model enables us to split a document into pieces. Okay? You can see into cluster of word by topic, because a group of words that come together, they're going to make a topic. Does that make sense? So you're going to have clusters of word by topics, and you're also going to have a cluster of documents by topic. I need you to see the two: cluster of word by topic, cluster of documents by topic. Okay, that is what the topic model will actually factorize that collection of text document into all of that. Okay, this is actually taken from Google Image. Now we want to bring in mathematical knowledge now, because if you want to learn, if you want to use computer or machine learning algorithm to learn from data, what we need to do is to first have our data, okay, in a numerical form. Let me tell you this: the text in document are not in numerical form. You know that, right? They just words. And what we're trying to do now, we want to generate the matrix, the raw data now. Now I told something the other time. Take a look at that. The raw data, the end document, like the collection of document for analysis, is what we call corpus. Okay. Now we need a matrix. Okay. We need a matrix. Okay. And we're actually going to call that a document term matrix. Please pay attention. Look at this. Document term matrix, DTM. The document term matrix is going to be, okay, I'm actually going to have document in row, and I'm going to have word. The term is the same thing as word. WORDS, right? We're going to have that one in column. Okay. And that's what you see. So each row is a document and each column is word in our vocabulary. And you know what SIJ represent? The SIJ here, the SIJ here is like the frequency. Like, okay, what is the numbers of time this particular word come use in this document? Does that make sense? That's what I mean by SIJ. So which is going to be the cell? Okay. Now, any question about that? Any question? Okay. Now what we want to do, processing that particular raw data to DTM can be complicated. Okay. And that is the reason why what we're going to do is to apply model. Okay. We're going to apply model. Okay. I need you to take a look at this guy. I want you to see how corpus, that we call the collection of document. Each document, don't forget, a document can be an article. Has any one of you seen a research article before on statistics or machine learning? Have you ever seen that? I think you guys are working on your project now. I will advise, of course, you're going to be reviewing some research or article. Article is always like that. if you take a look at this guy now, I have so many documents, right? I have so many documents. It could be a research article. It could be just it could be article on, it could be a daily newspaper. It could be maybe New York Times. Has anybody read from New York Times before? Or Washington Post? Okay. Or Georgia Constitution Journal, stuff like that. They're all going to be in Welsh. Look at it. Can I read from the first document? Yeah, it said we study the complexity of influencing decision through bribery. Those are the kind of things you're going to see in article. We're going to see in document, right? Now we got a collection of document. But you know what I want to do? Before we can use machine learning algorithm to learn the topic, the text, okay, the text that we have has to be converted to matrix. And that's what we're doing right now. Now, this is a matrix vector representation. Okay. Now, you know what I'm doing here? D1, D2, D3, D4, D5. They represent my document. Document 1, document 2, document 3 up to document 5. Of course, if you take a look at what I'm showing here, oh my God, this is document 1, this is document 2, this is 3, this is 4. I think it's hiding, right? How many document am I showing? I'm showing 5 documents, right? Now, with the 5 document, I'm actually going to use notations, which is going to be D1, D2, up to D5. Now, and I need some keywords. Complexity, okay? Complexity. I want to take a look at this complexity in this document. There's complexity here. Let me see, is there any other area where there's complexity? So what I'm trying to say in essence is that for document 1, how many complexity we want to know. For document 2, how many complexity. We may have a particular document that there's no complexity. That's why you see what is missing. Does that make sense? Now you can see algorithm, you can see entropy, traffic, network. Now, is there anyone here who doesn't understand how we can have numerical representation of the raw text data into matrix representation? Take a look at that. Is there anyone? So the matrix representation is going to be called a time document matrix. That time represent words. Okay, the moment we have that, the next thing that we're going to talk about is to look at the time frequency values in the matrix. Okay, and that can also be normalized or weighted. Okay, so take a look at, I'm going to show you something now. Okay, now TF-IDF. Okay, the TF-IDF, I said sometimes people feel the DTM would not incorporate the words relative rows in a corpus, but the time frequency inverse document that we call, the TF, the IDF is a numerical statistics to help. It puts higher weight on more informative words. When words are more informative, it's going to have high frequency. That's what I say. It's going to have more weight. Okay, less informative word is going to receive low frequency. That's what it means. Okay, now in the example, okay, it said if you document 1, may not necessarily be this, let's say in a particular document that I'm reviewing, if it contain the word apple 3 times, I'm just assuming, okay, and the word apple appears in 2 out of 5 documents. You have 5 different documents, and the word apples appear in 2 out of 5 documents in the collection of documents for analysis. Okay, then do you know we can actually compute a TF-IDF score for Apple? You remember the other time where we're dealing with Gaussian Mitchell model-based algorithm where we believe a particular item can be classified in more than one group depending on the probability assignment, right? Like we can say, okay, there's high probability, maybe 70% that this item is going to be in group one, and maybe 5% probability that it's going to be in group two. We're also going to have it, you know, you could have Apple could appear 3 times in one document and appear only one in another document. Does that make sense? So here we're trying to say the word Apple appears in 2 out of 5 documents in our corpus. Then our the TDF IDS score for Apple in document 1 can be calculated. In document 2 can be calculated. And that is actually going to be the frequency of Apple in document 1 multiplied by the log of the total number of documents for analysis divided by the number of documents containing Apple. It's not going to be all documents that will contain Apple. You know that? That will contain a particular word. Now I'm showing you the formula to figure out the TF-IDF score for Apple in a particular document. Okay, I'm going to move right now. I want to tell you that text data is a standard motivated data. Why is it motivated data? It's a motivated data because every motivated data can be represented as a matrix. And text data here can be represented as a matrix because we have a document by what? By word. Does that make sense? So that's why. And let me tell you this. I said we can deal with the text data as a standard motivated data, which means we can use the idea of PCA, the principal component analysis can be used. We can use the idea of clustering. I mentioned clustering today when I said, a particular word may be in this document and also be in another document, but the numbers of times it appears in the particular document may be more than in another document. That's a clustering. We can use a clustering approach too. Then we can use MDS. Can somebody tell me why MDS is coming in? Why is MDS coming in? Multidimensional scaling. The MDS is coming in because we actually want to project, from the high dimensional space to the low dimensional space. Why am I interested in searching, predicting topic in the first place? If I have the time, I would have just spend my time on the paper and search out the topic without using model. The essence of the model is to save us time to make a prediction without necessarily going through the entire document with some keywords. Can I just extract some hidden topics? That's what I mean. Okay, so I wanted to take note of all of that. And I said, because of the language nature of text data, we hope that by incorporating additional structure of the language, we can produce more informative results. We're doing all we're doing just to make sure we have informative result at the end of the day. And I said, therefore, we want to design special methods and hope for better accuracies and interpretability. Okay, that's what we hope for. Okay, now basic structural assumption of topic models. Let me tell you this. Every statistical model has assumption. A model is good as assumption put into a model. What make a model to be fantastic is when assumption hold. So like every other statistical model, okay, topic model has assumption. And I need you to pay attention. Okay, each document, it is believed that each document consists of a mixture of topic. Each document. When you read an article, you're actually going to see different topics on a particular article. For instance, if you get a national newspaper, you're actually going to see a topic that's centered on sports, a topic that's centered on economy, a topic that's centered on social, and so like that. Okay. And I said each topic consists of collection of words. This is an assumption. Of course, what we want to do in topic modules is, why do we call it topic modules? Topic modules. A modules that will review the topics. And the only thing we've done is to look at words. Okay, words in documents. Is there a way we can tell about the right topic? Okay, then there's something that we call the back of word assumption. Okay, so from the module, it is the order of the word does not matter. The order the word appears doesn't really matter to us. Okay, just have to take note of that. And what we're going to use as input here is DMT. When I say DMT, I mean document term matrix. That's going to be our input. Okay, now I present to you. There's so many statistical machine learning technique that can be used that are as topic models. This is one of them. Latent semantic analysis. We have latent semantic analysis. Let me take you back so that you'll be able to see so many types of topic models that we have. Take a look at that. We have latent semantic analysis. I'm going to walk you through that. We are the NMF. I've walked you through NMF in this class before. Okay. It's also a very useful model in topic modeling. Then latent, the correlate allocation that will involve the knowledge of multinomial distribution. Then I'm also going to talk about probabilistic latent semantic analysis. But where we are now, we want to start with the first topic model. Before moving on, is there any question? Before I go into the latent semantic analysis, the latent semantic analysis is one of the topic models. Is there any question? So far, so good, right? Okay. I'm going to say this guy is one of the oldest technique of topic modeling. Okay. And of course, it's a very basic. It's not the real. And that's why it doesn't really make sense to me. Okay. But I just want us to start from somewhere. Okay. And let me say this approach, if you understand the principal component analysis, you'll be able to understand this approach, because the principal component analysis actually use the idea of the composition of matrix. So this approach are also going to benefit from that. And that's what I said, essentially an equivalent procedure as a principal component analysis. Now, I think I got a lot of stories on this approach. Okay. Now, you know, why are we viewing this approach as a fair principal component analysis approach? Do you remember that in principal component analysis, did anybody remember a biplot? In biplot, what do? We actually project a data point uh into two dimensional space, row and column. Do you still remember that we did something like that? Where the features I guess some kind of angles, okay, at angle 90, they are orthogonal. Okay, when the lines are very close, it means they are related, stuff like that. You remember a biplot. Okay, so but because this guy is also a document word, like a column, column word. I'm sorry, column row situation. Okay, it's actually should be reminding us of a biplot in PCA analysis. Okay, and let me tell you this. I said something here, embedded document with similar word usage together. Okay, so that's what I mean. An embedded word with similar use in corpus together. Okay, now the moment you understand that now, let's see how it works. And I need you to pay attention now. Latent semantic analysis. If you really want to understand it, if you understand the singular decomposition. Okay? if you understand the singular decomposition of matrix, then you will be able to understand how the latent semantic analysis as a topic model work. And I need you to pay attention now. Because matrix is going to be involved, right? The matrix this time around is actually the combination of the document and words. Now take a look at this. The matrix, why? Let me just walk you back to SVD, singular value decomposition. You know what SVD does, right? It's actually going to decompose made into the lower matrices U, D, and the transpose of V. But you know what? What we want to decompose right now is the matrix of document and word. Matrix of document and word. That's what we want to. So if we take a rank K truncated version of the SVD, why do we take a rank K truncated version? We're not going to use all of them. Don't forget, if we use a full rank, okay, it means we're retaining the full dimension. We're not interested in retaining the full dimension. We only want to settle for the K, like the one that will give the IES a singular value is what we're looking for. Now, take a look at this. That's why we're actually having that. Okay. But if I have U, D, and V, the singular value decomposition will decompose that matrix into U, D, and V. Now the question now is, what is U? What does U represent when it comes to topic model? What does D represent? What does V represent? You all know. If we have a matrix, right, and you do a singular value decomposition, we're always going to get three matrices. But we want to know what each of them represent in topic modeling. Okay? Now, each row of the matrix U, okay, we give you the representation of the corresponding documents. Please pay attention. Take a look at this. Each row. Don't forget, of U, where is U? The U is inside here in the singular decomposition. Okay. Now, and each row in V, each row in V is a representation for a word. Do you see that? It's like it's trying to decompose the document into a vector of word and a vector of, document itself. Okay. And of course, you actually are going to have a D. And that very D is likely going to be a diagonal. The diagonal matrices, we're not going to use all of them. Does that make sense? And don't forget, we actually apply this approach. I remember when we were dealing with compressing image. You remember when we're compressing image? Exactly, we did something like this. Okay, now that is how. So the LSA that we call the latent semantic analysis uses the approach of SVD, like I said. Okay, so the topic interpretation is very vague and artificial. Okay, we're just talking about the disadvantage of that. I does not really take any special property of test data into consideration. And that is the reason why I say it doesn't make sense to me. But that's a naive approach. Okay. But let me tell you this. Some approaches that make sense in text modeling when you talk about this guy. You remember we've done this before in this class. Non-negative matrix factorization. I'm going to tell you this. In the non-negative, it's like you have a matrix X, and we now impose a condition. We want to decompose this into two lower matrices, and each of the lower matrices must not be negative. We all know a weight can be negative, a count of words. Can we have a negative count of words in an article? No, it can be negative. Does that make sense? Now I need you to take a look at the mix now. Take a look at this guy. The combination of documents The combination of document is more or less our matrix, right? We now want to decompose that into what? Set of words, okay? A set of word found, and another vector is going to be the weight. What do we mean by the weight? The frequency of which word. And so which means this guy here is the W, and this guy here is the H. Do you know I can have a way to reconstruct? If I want to reconstruct, okay, the set of dictionary now, I only need to multiply W by H. But multiplying W by H will not give us exact. I told you the other time. It's going to be a gap. So I'm presenting to you a non-negative matrix factorization can also be used as a topic model. Okay. And this is so fantastic. This is an improvement on the LSA method that I presented to you the other time. Okay, take a look at this. I said directly apply to the DTM. What is the DTM? Document term matrix. And I said, and the non-negative is used. That non-negative is a keyword because there's possibility you do a singular value decomposition and you have a negative. But this guy actually imposed non-negativity, which makes sense when it comes to the number of word counts. The number of the word count cannot be negative. We all know that. And the number, okay. So I said each document is a mixture of multiple topics, and each topic is associated with word. Take a look at that. A topic associated with some word. Okay. And not only that, document is also a mixture of topics. Okay. And because of that, because of the non-negativity, we're actually going to say this make more sense compared to LSA. Now, I want to go to the next one. It's another approach. I'm just introducing you to them today. Like tomorrow, you're going to see me, we're going to look into them deeply. How we do it in R when we have data set, like we have documents. How do we go about it? Okay, all of that. I'm actually going to